Alright guys, welcome to another one of the Sketchy Notes. So in this case, we're actually drawing out a small barbell, okay, and particularly for the hexagon shape, because as we were seeing in the fast-paced sketch, what took about 10 minutes, to go ahead and put in the overall dimensions, setting a scale, picking through to go ahead and get a lot of the typical measurements. The thing that's easy to go ahead and get with a tape measure or a ruler, the width, the overall width, the height, okay, and a lot of those, the things that are easy to get. But then we're going to go ahead and, of course, slow this video down and get into kind of the tougher stuff. So let's finish this up and go from there. So now that we have most of the drawings and dimensions done, let's talk about how we can go ahead and use some of our mathematical tricks to take care of things that maybe we can't easily measure of our physical objects, and how we can go ahead and kind of address the unknown angles, because angles can be another good way, especially in your polygons, to go ahead and fill in the information that, again, unless you've got a compass or protractors, you may have some trouble getting those measurements. So what we can remember is that there are a couple of mathematical formulas that help us in terms of setting up our polygons. Okay, so one of them is, we know that in any triangle, okay, we have 180 degrees, okay, of interior angles that have to match up. Okay, so 180 degrees inside, and then outside we have to have it set up a whole 360, okay, basically creating a full circle around the object. So for this to apply to our polygon, okay, doing just a quick sketch polygon to kind of complement what we have, okay, set a point, okay, and then from that point make the number of triangles that you would need to connect that point to every other point. Okay, in this case, it's connected there already. Okay, we end up with 1, 2, 3, 4 triangles. Okay, 4 triangles. So 4 times 180 degrees. We would be able to go ahead and calculate it, 400 plus another 32. So we should have a total of 720 degrees on the inside. Okay. Now, as a regular rectangle, okay, all of these corners are pretty much going to be the same. So we can take that 720 divided by the 6 corners that we have. Okay. And we know that we've got about 6 times 2. So we should have 120 degree angles in each case. Okay. Now we also know that on a straight line, okay, similar to what we're creating with our extension lines, once we know that interior angle of 120 degrees, okay, these are going to be 2 equal angles as well. Okay, so to get that whole 180, we know that we've got to add another 60, so we'll have 30 there and 30 there. Okay, again, just reviewing some of the basic math skills that you probably remember with some geometry and trigonometry. So, not wanting to mark on the inside, okay, we will go ahead and set up a couple of extension lines so we can fill in our angles. And it's okay to go ahead and kind of have them go a little further out, okay, so we know that they're in extensions of the lines that we're working with. And we know that that's 30 degrees on the top side, another 30 degrees. And if we actually went into the CAD software and we start putting in these dimensions, we would actually be able to go ahead and create something that has the suitable sizes, because sides, we're basically assuming that those are going to be equal lengths. The angles are basically forcing the edges. In a CAD software, we might also have some geometric constraints basically saying that this top line is going to be parallel to the bottom line. but we're able to go ahead and quickly define it using some of our other mathematical knowledge. The other part that I want to go ahead and touch on is we have a lot of different radiuses. Okay? We have rounded over, fillet edges, on a lot of points. When we're looking at the barbell, it's smoothed over, okay, pretty much at every point. So rather than having to put in a fillet radius for every single one of those points, okay, what we can do is we can basically point to that fillet. Okay, could be an interior one, could be an exterior one, but in this case we're basically just putting a quick note. And if we say that the radius there is 0.1 inches, if we include TYP, okay, that's basically saying that typically anytime we have a radius, okay, anytime we have one of those fillets, it will automatically be telling us that we assume that that is that 0.1 inch radius. Okay? So mathematical tricks and knowing the some of the typical symbols to say we're repeating this information makes it a little easier to go ahead and quickly and accurately describe your shapes. So saves you from some actual measurements you may have to take in real world because we're using some mathematical assumptions to go ahead and explain what we're looking at. So hope this helps on your sketches, and I'll see you next time.